For the same reason that exponential equations, when we have the same base, then the exponents are equal. For exactly the same reason, when we have a logarithmic equation and the bases of the logarithms are equal, then the arguments will be equal. For example, if you look at the log with base 3 of 5, and you set this equal to the log with base 3 of 4 plus 1, then definitely these two logarithms are equal. Why? Because they have the same base, and since they have the same base, we are talking about the same number. Let's make this even easier. Assume that you have the log of 9 with base 3 and the log of 8 plus 1 with base 3. Log of 9 is nothing else than the log with base 3 of 3 squared. So this is equal to 2. Since this is equal to 2, this is a specific number, let's look at log of 8 plus 1. But 8 plus 1 is 9. So this is also log with base 3 of 3 squared. So of course, again, this is equal to 2. There is no way that we can have two arguments here that they are different from each other with the same basis and their logarithms are equal. This can never happen. So let's look, if we have an unknown, if we have an x in our equation, what happens? Well, it's the same case. Since we are talking about a number on the left and a number on the right, we don't care what this number is. It can be 5, it can be 11, it can be 100. If it is 100 on the left side, it will be 100 on the right side. So basically, what we are saying right here is that we have two numbers that they are equal. Since these two numbers depend on the same base of the logarithms, the arguments x plus 4 and 11 must be equal. So in this case, how we solve our equation? We set this x equal to 11 minus 4, and the result is 7. And what this tells us is basically that log with base 3 of 7 plus 4 is equal to log with base 3 of 11. That this is exactly what we were expecting. So, whenever we have bases of logarithms that they are equal, their arguments are equal too. And this is how we solve the problem. Now, what happens if the logarithmic bases are not equal to each other? So, for example, or actually, let's try a problem where the logarithmic bases are equal, but we have a more complicated situation. Let's assume that you have logarithm 3 here, base 3, plus logarithm with base 3 again of x, and we want to set this equal to, let me make this 2, and we want to set this equal to log with base 3 of the number 3. Now also we can see that this is equal to 1, since the base and the argument are the same. How do we solve an equation like that? Well, the first thing that we need to make sure that we understand is, in order to solve an equation with logarithms, the equation needs to be of the form log of something equals to log of something. This is extremely important. There is no way that we can have two logarithms on the one side or the other side. So the first thing that we need to do is to apply the logarithmic rules here in order to get rid of one of those logarithms. So what we have is log of 3, and since we have a plus right here, then we have a sum of logarithms. So this is going to be the logarithm of their product. So this is going to be equal to the logarithm of x minus 2 times x. And this is equal to the log with base 3 of 3. So now, as you can see, what I have is a log with the same base right here, the base 3, on both sides. This means that these two logarithms are equal. These are two numbers that they are equal. And since they are equal, what we can do is basically focus on their arguments. The arguments must be equal to. So I have x minus 2 times x is equal to 3. This gives me x squared, if I perform distributivity here, minus 2x is equal to 3. If I push everything on the one side, then I have x squared minus 2x minus 3. And this is equal to 0. Right here, what I get is a quadratic equation. So what I need to solve is a quadratic equation. The way to solve this is a specific way, any way that you already know. You can either use the quadratic formula or the AC method. If I use the AC method, let me just review the AC method for you. A times C, in our case, is going to be negative 3. So I have two possible pairs of factors for that, either negative 3 and plus 1, or plus 3 and negative 1. Well, if I choose the first pair, negative 3 and 1, and I add them up, the result is negative 2. And negative 2 is the coefficient of the middle term. So that's the pair that I should split. So I have x squared minus 3x plus x minus 3 equals to 0. I factor out the x from the first side and I have x minus 3 plus x minus 3. And now I factor out the entire parenthesis of x minus 3 and I have x minus 3 times x plus 1. And this is equal to 0. This gives me two solutions. Either x is equal to 3 or x is equal to negative 1. What we need to be careful though when we solve logarithmic equations is that we need to check our solutions. Not both solutions are going to be correct. The reason for that is that if you consider the x equals to negative 1, then at the left side, you should consider this logarithm, and this logarithm will become log with base 3 of negative 1 minus 2. And this is log with base 3 of negative 3. But as we know, we cannot find logarithms. They are not defined, the logarithms of negative numbers. So this means that this is impossible. We cannot find that. This is undefined. If this is undefined, then this means that this is incorrect. And this means that this solution is not correct either. So the only solution that we get for this specific problem is that x is equal to 3. If you plug in the number 3 on the first, you get the log of 1 with base 3. If you plug in the 3 in here, then you get the log of 3 with base 3. The log of 1 with base 3 is 0. The log of 3 with base 3 is 1. So 0 plus 1 is 1. And the right side is 1 as well. So your result is 1 equal to 1.